Alright, today in class we learned all about box and whisker plots. So we learned how to construct them. We learned how to find the median, the upper quartile, the lower quartile, the inner quartile range, and how to find outliers. And then we also learned how to describe the distribution of the data. So the range is the difference between the greatest and least values. Quartiles divide data when arranged from least to greatest into 4 groups, each with a fourth of the data. So we had a big discussion about is standard deviation the same as quartiles, and we decided that no, it is not. Standard deviation, if you're 1 standard deviation away, then that will take into account 68% of your data. If you're 2 standard deviations away, remember that it will take into account 95% of your data, and if you're 3 standard deviations away, that's 99.7% of your data. So here this just divides it into 25%, 25%, 25%, and 25%. The median divides the data into upper and lower halves. We also know it to be the number right in the middle. The lower quartile is the median, or the number in the middle of the lower half, and the upper quartile is the median of the upper half, or the middle of the upper half. The inner quartile range, I call it the IQR. This is the difference of the upper quartile and the lower quartile. An outlier is found by taking 1.5 times the inner quartile range and subtracting this number from the lower quartile and adding it to the upper quartile, and then looking to see if there are any data values beyond those numbers, and if there are, they are considered outliers. A skewed data box and whisker plots look like this. The first one is negatively skewed. This reads that the left whisker is longer than the right, and the median is closer to the shorter whisker, so this is negatively skewed. Symmetric is everything's the same, they're the same distance from the center. And then positively skewed is the majority of our data would be on the left side. The other thing that we discussed here is that from here, this is known as your greatest, or excuse me, not the greatest, the least value. This number here is your greatest value, and I usually just put a dot out there and not a bar. Our median is right in the middle. This bar represents the lower quartile, and this represents the upper quartile. Another thing we discussed is that between the least value and the lower quartile, 25% of your data will lie between there. From your lower quartile to your median, that's another 25%, and from your median to the upper quartile is 25%, and then from your upper quartile to your greatest value will be 25% of the data as well. Okay, so on this example, we are going to find the mean, the upper quartile, lower quartile, inner quartile range, and any outliers to construct a box and a whisker plot. So to do this, the first thing you have to do is put your numbers in order. I just did that really quickly, and from here, once they're in numerical order, look to find the median first. The median is the number in the middle, so here our median is 32. From there, I look to find the lower quartile, and it's the middle of the lower values, so we can see 18 is right in the middle of the lower values. We do not include the median when we're looking for this number. Your upper quartile is the middle of the upper values, so we can see that that's 41. And then we will need the inner quartile range. This is your upper quartile minus your lower quartile. This is 23. And then we're going to use this number to find if we have any outliers. So, outliers. To find outliers, we take 1.5 times the inner quartile range, which was 23. And this gives us 34.5. From there, we're going to use that number. We're going to take the upper quartile and add 34.5, and then we'll also take the lower quartile and subtract 34.5. So when we add it to the upper quartile, we get 75.5, and when we subtract it from the lower quartile, we get negative 16.5. So we're going to look at our data values and see if there are any values above 75.5. Our greatest number is 52, so no, there are no numbers above. And then we're going to look, are there any numbers below negative 16.5? So that's also no, because our smallest number is 16. Then from here, so that means that we have no outliers. From here, we're going to draw our box and whisker. I'm going to go by 5s. And then we look at our first value that we graph is our smallest value, and our smallest value is 16. I graph it by putting a dot there. Then you graph your next value, which was 18, and it is my lower quartile, so I'm going to put a bar. The next value I graph is the median, which was 32, and I graph it with a bar as well. After that, we graph 41, and then our greatest value was 52. From here, we make our box. Our box is from the lower quartile all the way to the upper quartile, and then our whiskers just extend out to those values. Okay, on example 1b, we're going to do the same thing. The first thing you'll do is put them in numerical order. I just had to switch two numbers. Then from here, we're going to find the median. That is the number in the middle, and we don't have a number in the middle, but what you can do is you can either add those two and divide by 2, or you can see that 16 is right in the middle. Then we will find the lower quartile, and that's the middle of the lower values, so it's 14 here. The upper quartile is the middle of the upper values, so 18, and then our IQR, interquartile range, is the upper quartile minus the lower quartile, so that's 4. Then we're going to try to find out if there are any outliers. Okay, so to find out if there are any outliers, we take 1.5 times 4, which is 6. We're going to take this value and we add it to the upper quartile. So we take 18 plus 6, that's 24. We're going to look and see if there are any values above 24, and yes, there is. It's 44. Then our lower quartile, we're going to subtract 6, so 14 minus 6 is 8. We look to see if there are any numbers below 8. Since 13 is our smallest number, we don't have any below. So what this tells us is that 44 is an outlier. So the last thing you'll do is you'll graph it. I think I'll go by 5s again. So we start out by graphing our smallest number, which was 13. It's about there. Then we will graph the lower quartile, which is a 14. And then our median, 16. Our upper quartile, 18, and that should be our box. And then we have an outlier at 44. If it's an outlier, we don't connect it with a whisker, so we go to the next smallest value. In this case, the next smallest value is actually 18, and it's on our upper quartile, so I'll just put a dot there. And then we extend our whisker to that point. And there's your box and whisker. Okay, on example 2, you're going to use a graphing calculator to do this. So the first step you're going to do is to go into Stat and then press Enter and enter this list. Once you have it entered, you're going to go to second y equals, which is your stat plot. And you're going to change it so that it is using a box and whisker. We're going to choose the first one because I like to see if we have outliers or not. And then once you have that stored, you're going to zoom 9. That takes it to a statistics window. And then after that, we're going to look at some of the specific numbers, like our greatest value, our least value, our interquartile range, our median, in the quartile 1 and quartile 3, which is also the lower quartile and the upper quartile. So we'll also go to Stat, arrow over to Calc, and choose 1 and enter. And that one, number 1 is a one variable statistic option, and it will give you lots of information about the one variables. So when we graph this in our calculator, it looks something like this, with an outlier out here. So we can see, first of all, that it's pretty symmetric, excluding that outlier. And then the other ones, we want to find what each of these major values are. So to do that, we go to number 4, which says you're going to press Stat, arrow over to Calc, press 1, which is a one variable statistic, and press Enter again. And then we scroll to the very bottom. It will give you your min value. Our min value is 5. It gives you your quartile 1, which is your lower quartile of 22.5. I'm going to write these numbers in. It gives us our median. Our median is 36. I'm going to write that above. Then it gives you the quartile 3, which is your lower quartile of 48.5. And then it gives you your max value of 95. Now when you were typing this in, you probably thought, hey, that number 95 is probably an outlier because it's so far away from the rest of the data. So the last thing that you're going to want to find is what this number is here at the end of your whisker, and it should be the next smallest number. According to our list, it is 65. So if you'll identify those 5 pieces, we call it a 5-number summary. If you'll identify those, what kind of distribution it is, then, and also draw a graph for me on those examples or those problems. Okay, example 3 is just going to give you some box and whiskers to compare. A says, which class had the higher median? Remember, the number in the middle is our median, so we can obviously see that B is better. Which class has the lowest score? That would be this value here, so class A has the lowest score. C, which had the smaller interquartile range, that's your box. So we can see here that class A has a much smaller box, so we would say that it has a smaller interquartile range. Which class would you rather be in? Now this is, I had a lot of kids say B, and some say A. The reasons why they would say A is because they'd like to be the smart one in A, but then we talked about how if there are lots of smart kids, for example, if there's lots of smart kids here, then you're more likely to be pulled up and achieve with them. So eventually we said that B would be the better class to be in. Alright, that should help you with your assignment 7-3 box and whisker plots.